look at the first question from the Chief Mate's paper. We're given the alternative stability criteria for a timber vessel, and we're given our displacement in kg, and we have to draw the curve and see if this vessel complies. So with alternative criteria, you generally be given the information to check to see if the vessel complies. So we talk about the KN tables. Well, in the booklet, of course, there's our KN tables that I'm sure you're well aware of. So to draw the curve, first thing we have to do is to find the KN values, then kg sine the angle, kg sine the angle, always kn minus kg sine theta. So on the formula sheet, that's the formula that you will always use when drawing a GZ curve. So we get our GZ values. We also need our GM, because when we draw the curve, we must put 57.3 degrees, the GM value 0.22, draw the line across, and then draw our line from the intersection to 0. And then we would start the curve off along that line. And always draw the curve as large as you possibly can, make it more accurate. So we'll draw the curve, and then at this point, of course, we can pick off the 10 degree value that we will need, because once we've got the values, the 10 degree value, we can then work out the area under the curve. Now we have to work out, is it 40 degrees or is it the angle of flooding? So if you go in your tables, you will see that at this displacement the angle of flooding was 43.5 degrees. That exceeds 40, so we only work up to 40 degrees to work out the area under the curve. And it's the straightforward 141 rule, 14241, gives us our product area, work out the area under the curve, and we can see that exceeds the minimum of 0.08 told us in the question, therefore it complies. GM 0.22 exceeds, so it complies, and the maximum GZ 0.32 exceeds the 0.25, so this vessel complies overall. So quite a straightforward question, where you're given what you need to check against and draw the curve, work out the values, and that's, I think, quite a straightforward question.